So in the last class, we talked about various dimensionless numbers. So those, all of them are being used in fluid mechanics, but something for UG, something for higher level fluid mechanics. Is wherever you have a transportation of any fluid actually. So it depends what force is, which force is the dominating. Based on that is being characterized whether we want cavitations or sometimes stretching or sometimes compressions, sometimes buoyancy means perfect, sometimes free flow. So based on that, you have to choose the number actually. And dimension analysis, the important part is that these are being used when we want to scale up the things actually from experimental the level to a actually a pilot plant and or let's say finally a commercial plant. So there are some criteria that need to be fulfilled for to this scale up process. So scale up process is being applied in every part. Means just like either you are making a computer chip. So let's say you are making a chip for a mobile and then chip for a laptop and chip for a supercomputer. Based on that, you are increasing your magnitudes. So based on that, what factors need to be considered? What should remain a constant so that the scale-up process can be applied? So this is called the first is a model type and then a prototype. Prototype is called a full scale one. So let's say in case of the fluid mechanics, if we are talking about scale up of the fluid mechanics part, let's say you have a pump. Now you have made a pump, the smaller diameter pump impeller, and that can lift the water, let's say up to let's say 30 feet. Now you want to design a pump with a big impeller so that you can increase your flow rate. But had you want 30 feet, you want had only 30 feet, you have impeller has been increased. So how this your power, your RPM need to be controlled. So that comes from a number is called a power number. So whatever power number is there for your model type, same thing has to be there for your prototype. That number should not change because that number is combination of the several parameters, your density, your RPM, and your impeller diameter actually. Okay. So based on that, we will come to know here that how this thing would be done. So there are something is called in case of dimension analysis. First thing, let's say you are going to model to a prototype. So its appearance should not change. Just like a architecture makes a building, yeah, he makes a demo on a thermocol piece, right? You can see a live model of that, but the civil engineer finally do the constructions of that and finally you came up with the same building. So whatever, however, its appearance should not change. It should look like same, whatever you design in model, what is in actual. That is called similarity analysis. Okay? Hello, anyone can the respond
Yes,
something?
sir.
So
Yes.
they should look same from model to prototype also. That should not. So you have the something here, and first thing is called a geometric similarity. The model must be of same shape as the prototype, but maybe scale up by some constant factor. Means there could be a factor by chance, let's say length of the model to prototype has been increased a factor of 2. It means all dimensions need to be changed by that one. Only then you can retain that particular shape. Otherwise, your shape would get distorted. So that is called geometric the similarity. Their appearance should look same. Whatever magnitude the things has been changed, it should change by all dimensions the same way. Next similarity is called a kinematic the similarity. This say that velocity at a point in model flow must be proportional to your prototype actually, and that can multiply again by some factor. So let's say you are calculating velocity at the tip of the impeller. So same should be velocity in the in model type at that particular the location. It can change from location to location, but at a particular the location it should scale up by same factor, maybe a factor of 2 or 3, or let's say 0.5, 0.2, 0.3. So it should be a factor of same at every point. That's called kinematic similarity. We will show means all of them one by one. Then you have a dynamic similarity. Dynamic similarity that all forces in the model type forces. Dynamics talk about forces must be scaled up by a constant factor to the prototype. Means the whatever force you need for the model type, the prototype should also need the forces in some multiplication of that. So we will do all of them one by one. This is what you have. First, we were talking about for your geometric similarity. Let's say from here, this is a bigger one, and then let's say you went to, so all of them are rectangle. You see here, this is also the rectangle, this is also the rectangle, this is also rectangle. Each dimensions has been increased by a same factor. Okay, it's not like that. Length can be changed by a factor of 2, width can be changed a factor of 3, and height can be changed a factor of 5. No, it's not that way. Every dimensions must be changed by same factor. That is called a geometric similarity. Your geometric appearance should not change. Now let's say for forces part, let's say you have some force at this particular point. If you will correspond to here to this point here, it should also have the force in the same direction. The direction of the force here also should not change. Only thing is magnitude can change, and magnitude should not change by a different scale factor from here to here. It should change by same factor. If the force corresponding to here has changed by a factor of 2, it means it should change factor of 2 also here also. So all corresponding points from model to prototype should change by same magnitude. That's called your dynamic similarity, the forces. So dynamic similarity talks about forces only. Kinematic similarity say actually velocity. So you can see this figure here. Can you see this figure? So in this figure, if you see that if this is the velocity direction here, if the velocity direction here change here, it means this is not a kinematic similar model. It will not perform as you have done practical on the model type, because here the direction of the velocity is completely horizontal. Now here direction velocity, one velocity is going this side, other is going this side. No, these are not kinematic similar, because direction of velocity has been changed. It should not be. It means, let's say on this particular plane, if this is the velocity here, this plane is horizontal, is there. Now you see on top plane here, you can see the top plane direction of velocity here and this side, both are in the same direction. They are parallel. Yes or no? You see this velocity and this one are going in parallel side. It means at this age, the direction of velocity is same. Correct or not? So,
Correct.
so this means they are kinematic similar. So wherever at a particular point, whatever direction is there, same thing should be the direction in the prototype also. If that is the happening, only thing is magnitude is changing. Here it was the bigger one, here is the smaller one. So only thing their magnitude has been changed, direction is no change. That's called a kinematic similar. Same thing forces part here. Let's say this is the model here. This is the lower one is the model. This bigger one is your prototype. Now in this case, you see here, this is the magnitude of force, Fd. This is the force. Now this has been changed by its magnitude. Only thing is magnitude has been increased. Rest of the things are same. Direction is same. Direction of the force is same. So these two things are the first one is the prototype, and second one here is the model type. It means these two things are geometrically similar also, kinematic similar also, and dynamic similar. It means this model will work. If these are not are similar, it means your scalar process is of no use. The things, whatever you do, it will not coincide with your calculations. So these three similarities must be checked all the time when you go to model to prototype. Now, before doing that, how to scale up? Which number need to be considered? Just like that you have heard the Reynolds number, your coefficient of friction, then you have got a pressure coefficient, cavitation number, Euler number, power number, flow number, head coefficient. Several the numbers you got. All of them cannot be applied in a particular type of problem or particular type of a project. Each project cannot have all of them. So you have to see what can be used in a particular problem or a particular project. Okay, so that will come from your means problem, means experience and all this. So so based on that, you see what parameters are involved in your project. Let's say you want to design a pump. So pump may, what can you have? Pump need a power. It need a RPM to move the impeller. It need a density of the fluid. What else it needs? It have some diameter. It can give some flow rate Q. और क्या हो सकता है? It can give some pressure also. What else can be? Hello? Hello?
Yes, sir.
So you have to always think what are the various variables are involved in a particular project or particular machine. You have to list all of them. That's like in your chemistry, you have learned something is what is that? Hess law? कुछ पढ़ा था हैश लॉ और समथिंग और जैसे आप कुछ न्यू कंपाउंड बना रहे हैं ना यू आर कैलकुलेटिंग ए मॉलिक्यूलर फार्मूला ऑफ ए कंपाउंड. So you are considering each and every element. Now you are putting factor 2, 1, 3. How are they correlated? That you are calculating the later on. So same thing is just like that. You are making all possible combinations of the variables, and then you see which one can satisfy your problem. That's what you might have done that somewhere in your 12th, right? Same thing we will do here in our dimensional analysis also. So with the help of question, you will come to know. So these dimensionless parameters are called pi groups actually. Okay. Whatever the dimensionless parameters you will get, that's called pi group. Now, how to do that? That we will explain here. Just like this is the another example. This is the model car you have, and then you have made a prototype car. So here, this is the length of the car. So model type, so prototype, it has changed by this much factor. Then velocity here, then velocity this side. So you have here, this car would have some length. It will feel some drag force. It will have some velocity. It will flow. It will move in some fluid, just like air, which will have some viscosity, some density. So based on that, you are calculating, let's say this car would have, once it will run, it will feel a drag force. Drag force is the function of the Reynolds number something, right? So actually the number came, the Reynolds number here. How would it come? That I will tell you. Just wait for that. So the Reynolds number here. Okay. So for this, you are getting a 2 pi group here. Let's say one is this. This is for a drag force, drag coefficient, FD upon something. This is again a Reynolds number. So how would it come? I will tell. This is another example. Let's say from model to prototype, your directions of the force something. So this we will do the later on. So this based on that here the calculation came. So this is that example. No need to focus here. This is again, you have gone to a prototype part. For prototype also, you have calculated your force, the reload number. So just skip this because you will get confused here for time. So first thing here, we were talked in that geometric similarity. Geometric similarity rules must be applied from model to prototype. It means your all dimensions should be scaled up or scaled down by same factor. So let's say your length, let's say for previous case you have a car. Car have some length, so its length should change by same magnitude. Based on that, its height should also be changed by same magnitude. Its width should also change by same magnitude. So this scalar factor should remain same for all dimensions, be it length, be it its width, be it its height, it should change by same magnitude. Same thing is being applied for its wheel also, each and every part. Okay. Finally, its total appearance should change by same factor. So this is called a scalar factor. That's called geometric similarity. That need to be. This figure I have already shown to in the base, the first one. So this is your model, this is your prototype, this is again your model, this is again your prototype, this is again model, this is again prototype. Because model is always a smaller one. Nobody make a big model and then go to the smaller one. It's not that way. All the time model is the smaller or reasonable the dimension. It's not a hard and fast rule that model should be always a smallest one. Model is always a convenient dimension only. Just like all these chips for your the mobiles and all this. So mobile chips are not your model. Your model is your laptop or your computer chips because that is your reasonable size. Based on that, you scale down it for your mobiles and all the mobiles, your microphones and everything. Now, in kinematic similarity, we have talked about that. This is the direction of the velocity sync. So you should they should follow the same velocity pattern. So you see the here flow pattern, velocity move this side. In this model type also, they are moving at the same time. So this is called kinematic similarity. Velocity corresponding to each point from model to prototype are not changing. So this is what you have here, just like a free flow or a baby, the nature or the propagation of the wave in some water or the liquids or any fluid. So this is what here that the wavelength here, this is the wavelength in the lambda p of the prototype. This is the wavelength of the lambda m for model type. So only thing they have scale up from model to prototype by a factor alpha only. Now this is again velocity for this here, velocity corresponding to here by this, and this has changed by some factor here. So same factor, everything has been changed. Height of the crescent also has been changed by same factor. So everything, whatever parameters are there from model are changing by a same factor here. At the same time, the shapes are also same. Shapes should not change. So you have geometric similarity also, you have a kinematic similarity also, and for dynamic the similarity, you need a force also. So for dynamic similarity, I'm talking about forces. What forces can you have? Well, most of the time, you have a viscous force in case of the fluid flow or the machine. You have a viscous force, you have an inertial force, you have a pressure force. Correct or not? So if you will take the ratio of the mean the inertial force upon the viscous force, so all the time you are providing some motions in some fluid or pump. Correct? What the pump is the doing? Why you are in case of the transportation of flow, you are providing some inertia just to move your particles. Correct or not? Hello?
Yes, sir.
Right, so you
Yes.
are putting some external force. External force is creating some inertia, or that force can be provided with the help of some pressure. So inertia, you are calculating some numbers based on inertial force as a reference. So if you have viscous force, fluid would have some viscosity. If you will divide your viscous force upon inertial force, you are getting this mu upon rho VL, which is nothing but your inverse of your Reynolds number. So that also need to be considered in case of dynamic similarity. You are also providing a pressure. So if you are just calculating pressure force upon the inertial force, you are getting this number delta P upon rho v square, which is known as a Euler number. That is again another dimensionless number. Then you can have a gravity force upon inertial force. Based on that, you are calculating GL upon B square. This is called 1 upon of FR square. That is called, sorry, what this the number is called a Frodde number. Gravity force upon inertial force. This is Frodde number. Then you have a capillary, you have a surface tension force in the fluid, again divided by the inertial force. Based on that, you are calculating sigma y rho v square L, that is called 1 upon a Weber number in case of capillary actions. Then you have a compressibility force. Your fluid can also get compressed by putting your force from outside. So that is compressibility force upon the elastic force. Based on that, you are getting this number 1 upon of Cauchy number, that is also called your Mach number also. Cauchy number ka ulta, that's called Mach number also. Okay. Uh, Now this is again from model to prototype. So I have already explained you how the model and prototypes. So the if you are calculating the means, now you have come to know from the previous thing, you came to know 5 numbers. One is there the Reynolds number, other one is the Euler number, then your Frodde number, then your Weber number, then your compressibility number. So if you are talking about incompressible flow, so you should not talk about compressibility factors, correct or not? That number will not be considered. If you are talking about flow on a compressed pipe or a flow in a pipe and channel, then gravity force doesn't play much role in that. So that Frodde number need not to be considered. If you are putting some external force from the outside, then the surface tension, your capillary rise, your diameter is too large, then capillary doesn't play the role actually. So your capillary number should not be, this Weber number should not also be considered. Where surface tension is not a dominating force, that need not to be considered. So most of the time you are ending with this one actually, this one, the Reynolds number is the major number which need to be considered most of the time in all cases. So that's what we have here. So Reynolds number from model type, what did the number was here? This is pressure coefficient. We have talked in the last class, delta P upon half of rho v square. That's called pressure coefficient. So you are from model to prototype. So model prototype of model ka RE and your prototype RE must be equal. Same thing, the pressure coefficient of that must be equal. Now you will what means would be confusing or considering what number should I consider for my problem. There are so many in the numbers. So that I will tell in this class here. So first thing is called a Buckingham pi theorem. He says that if you have a particular project or a design or machine or a flow something, first you list each and everything, just like you do in case of your dimensional analysis, right? What you do in that case? First you list all the parameters, then you write all their primary dimensions, then you are mean the grouping them, which can be clubbed together. So once you call a fundamental quantity, other is called a derivative quantity. Yes or no? Derivatives are the combinations of the two, correct?
Yes, sir.
Right. So same type of analysis is given by this Buckingham pi theorem. So this have some procedure. Let's follow that. First one is that list all the parameters. That's called number n. Now list all the dimensions of all parameters, means you have to give by chance you have a force. So you have to have ml square mlt minus 2, right? That's force, right? So you have to write all dimensions of each and every parameters first thing. Then found all primary dimensions. How many primary dimensions are involved in all parameters, whether you have only m or you have only length or you have only t. or you have all of them. Count them. How many are the involved? Let's say length, meter, temperature, time. So count everything of them. That is the mentioned as M. Now this is called something is called repeating parameters, that some variables or some parameters can be involved in more than one pi group or more than one dimensionless groups. So that have some guidelines that something cannot be treated as the repeating parameters and something can be treated. So these are the guidelines here first here that include all primary dimensions but not one of those at a time. Include all of them, okay, but one of those at a time, only one primary dimension. No repeating parameters should have dimensions that are a power of dimensions of another number. You should not have any parameters which have a dimension that is the power of another parameters that need not to be considered. Just like this. Let's say you are considering the repeating variable as your length. Another parameter also you have the area. So length and area cannot be considered as two repeating parameters because both have same dimension of the length only. Length is also meter and area is also meter to the power 2. So those cannot be treated as the two different repeating parameters. Either of that has to be considered only. That's what the meaning of that. Okay.
Yes, sir.
Now, now you hear in case of fluid, you have viscosity. Now, based on the practice of all practitioner, engineers, and everyone based on experience, they say that viscosity should not be chosen as a repeating parameters because based on their experience, it cannot come more than one dimensionless parameter. So viscosity will never be treated as a repeating parameter, means it can come only in one group, so this cannot be treated as the repeating parameters. At a general rule, these are the repeating parameters: your density of the fluid, your velocity. Velocity can be either velocity or RPM or angular velocity. Both are same as velocity only. Either of them, diameter or length. So these are the guidelines that if you have these parameters in your problem involved, you straightforward go over this rule that the repeating parameter would be your density or comma your velocity or angular velocity, or D or L. Cannot have both. D or L cannot be chosen. No, either D or L. Same thing for angular velocity or velocity. Either of them. Okay. Based on that, these would be your total number of dimensionless groups, your and total number of parameters minus your the repeating parameters, that's called your R. These would be your total number of dimensionless group in that particular problem. And those need to be considered when you want to scale up that particular problem from model to prototype. So यहाँ से आपको number मिलेगा. Let's do a question for that. आप लोग भी मेरे साथ ही साथ करिए so that you can understand what is happening here. So this is the question here. A fan assisted convection oven, the heat transfer rate to a roast is Q, that you are giving a heat to that the energy per unit time is thought to depend. So यहाँ पे ये दिया है आपको, is thought to depend on specific heat of air, that is Cp, temperature difference theta, that's the given by this difference, length scale L, density A or air density rho, air viscosity mu, speed of air is V. This is what is given in this problem because you are now a beginner, so you are not supposed to think that parameters first. First, let's say this say that if you want to do the heating in an oven, energy per unit time is thought to depend on so many things: specific heat of the air, Cp, your temperature, the mean the difference, let's say delta T, length, how much is the length of your body, air density, and viscosity of the air, and the speed, how at what speed the air is blowing on that particular object. Now, how many basic dimensions are involved in these variables? First, you have to identify that. After that, determine total number of pi group. Pi means total number of dimensionless groups. Need to characterize this particular oven. Evaluate those pi groups, mean how many pi groups are there. So first part, as I told in the Buckingham pi theorem, that your Q is the what which depend on so many things. So this is Q on left hand side. It is function here based on the problem is your heat capacity, temperature, the difference, your length, your density of air, your viscosity, and velocity. These many things are given in this particular problem. At this point, keep this particular the line,
Yes, sir.
right? So list all of them first, that your Q depends on so many things. After that, write the dimension of each parameters. So first part, that the number of basic dimensions included in these variables, number of pi parameters, these three things need to be found. Let's say what I did next. Now apply Buckingham pi theorem. What you say, list all the all parameters, every parameters what you have. So you have Q, you have Cp, you have H, your delta T, your length, your density, your viscosity, and your velocity. This total number of parameters, count all of them. 1, 2, 3, 4, 5, 6, 7. So total number of n is 7. Total number of parameters are 7 to you. After that, next step is write the dimensions of your each parameter. So this is Q. It is the, they say energy per unit time. So energy per unit time, your the energy is what? Dimension of the, means the energy is energy dimension, or let's say dimension of work. Work upon time is called energy per unit time. Correct or not?
Yes, sir.
You should note the dimension. Nobody is going to provide. I am not also providing to the dimension to. It is your part. So you should know energy dimension. Energy is just if you don't have any direct idea. So energy is practically is your joule. Joule is practically dimension of work. Work is force into distance. So you know the dimension of force multiplied by distance. That will give you the work or energy. You want per unit time, so divided by time. That's what I did here. So first on top part you have work upon time. So that is energy rate, work rate or energy rate. So that's what is your Q. After that, Cp is heat capacity. That's what they have the given here. They have given here a specific heat. It is the specific heat. Okay. So a specific heat is given by this L square T minus 2 and theta here. Okay. Then you have a temperature here. Temperature is given by a term theta only. Then you have length. Length का L ही रहेगा. Density would be kg per meter cube. So kg is mass, is called m, and meter cube in the denominator will give you L cube here. So that will come ml minus 3. Viscosity, you should know the dimension of viscosity. Do you know the what viscosity is? How would you calculate if you don't know it? Dimension of the viscosity is kg per meter second. How would you calculate if you don't know? Any idea how would you calculate? Hello? If you don't know viscosity dimension, how would you calculate? Anyone can help? So you should start from where the viscosity came to you in your picture. कहाँ पे आया था viscosity? First time you have heard in chapter 1 from, hello?
Yes, sir.
विस्कोसिटी पहली बार कब सुना था? यदि कुछ याद नहीं है तो ये डायमेंशन एनालिसिस योर बिकम जीरो ओनली विदाउट एनी
dv by
डाउट.
dx, dv by
dx
dx,
आएगा. If I
dy,
wrote by here, so it will come by. How dx will come?
dy.
So this is your Newton's law of viscosity, right? So if I don't know the dimension of the viscosity, I can calculate from here. What is first term? Shear stress, right? What is the dimension of the shear stress? What is shear? Force upon
Newton per meter square.
force upon area is called shear. Viscosity you want to calculate. So you can write this. What is this term dimension is? First is velocity. This du is the nothing but velocity. So you can write here velocity. I'm talking about the dimensions, so I'm not consider about d and all this now. So I first is velocity. Next one is delta y, which is nothing but your distance only, right? This I am talking about now in terms of dimensions. I can substitute all of them one by one. What is the dimension of force? Force dimension mlt minus
MLT
2.
minus 2.
So that is your dimension of force. Area is just L square. So if you don't know, you should start always from basic. Don't guess anything if you are not confident. Now velocity is just what is the velocity? Lt minus 1 meter per second, right? Correct or not? And denominator
Yes,
also
sir.
your distance L. From here you can get what your mu is. So if you will solve it here, your mu will come. कितना आ जाएगा mu? How much is mu from here? L will get cancelled from here. This you have one L here, you will get T minus here. Bolo, what will come?
So
Lt
M
minus 1
L
L,
mi-
L minus 1.
So you are getting M, L minus 1, T minus 1, right? This is
Yes, sir.
your dimension of your viscosity. If you want to write a unit, what will be the unit will come from here? kg per meter per second, right? That's called Pascal. So this way, if you have confusion of any of the dimension, calculate from here. If you are sure, that's okay. So you write all of them here. So you wrote here viscosity, you wrote now velocity. Now you count here how many primary dimensions are involved here. First came your mass, m is 1. You came L is 2. You got time t. You got a theta is temperature. There's 4 dimensions are involved here. These are treated as R. R equal to 4, number of primary dimensions. Okay, now after that, as I told you previously, what are the fundamental rules of the repeating parameters? I told you clearly. First, you see whether you have density. You have here. You have chosen other repeating variables. Do you have here velocity? Yes, you have here. I have taken that. You have here length or d? Yes, you have here length or d, either of that. So I have chosen that. Anything else you have here? There the one more, the repeating variable here, theta. So if you want to, some person will say, okay, I will take 3. You take the 3, no problem. It will serve your purpose. Why these 3 would not serve here purpose? You have to choose the repeating variable such way that your all primary dimensions should involve in that at least once in least power. That is the guideline. Choose the repeating variable such way that every primary dimension should come into that in least power. Getting the point? So if you will choose only L, V and rho, your theta is not involved in the repeating variable. So you have to always also add your theta also here. Okay? Hello?
Okay, sir.
So therefore, we have the included theta. By chance, if theta is not there in this problem, your primary dimension was how many? 3. So only those are coming in this. Only length भी आ गया आपके पास, density में mass चला गया, and velocity में your time bends, right? In least power. Only least power. Focus on least power only. Fine. So based on that, you got your R, your the repeating mean the variable here came m is 4. Now you can get number of dimensionless parameter. How many now? Your number of variables, parameters total, minus your repeating variables. I mean these can be used in many groups. So total is 7 minus 4 is 3 repeating groups. Okay. Now let's calculate one by one them. So let's do for this I shown you here. So let's say I want to calculate first dimensionless group. So I have chosen these 4 as the repeating variables, rho, v, and l, and now I want to club them with my first parameter there, which was the q dot, which is now chosen as a repeating variable. So I am clubbing that with that, and I am just putting each of them some power a, b, c, d, so that my this total thing should become a dimensionless group. So now I will do the dimension analysis of that as I did in my 12th standard, I think first chapter of physics. Yes or no? So I am now putting the dimensions of the everything. Now I am calculating by equating power. This I will say this is now my your dimensionless the group. So here the dimension of each fundamental quantity would be 0 only. That's what it will become now, dimensionless group. So based on that, I put the dimension of the density is power a, dimension of velocity to the power b, dimension of length to the power c, dimension of theta to power d. And now you have dimension of q is ml square t minus 3. Now balance these power, add the power of m. So first you balance the power of m. So m is here a. So a is, and here is 1. So m is a plus 1. This side power of m is 0. Equate that, you got a. Same way you equate the power of L, same way you equate the power of T, same way you equate the power of theta. Based on that, you got your constant A, your constant B, and your constant D, and then you can solve it, you will get the constant C also. Is this fine? Hello?
Yes, sir.
Respond here fast, otherwise we have to take the tomorrow's also class. So just so you got this pi group, first dimensionless group. Fine.
Okay, sir. Okay, sir.
Now we have to use. Now we have to change this q by the means the another variable which I not chosen as the repeating group. What was the next group there? Is your CP. CP we have not considered there, right? So now I am going calculating the dimensionless group 2. So now I have the same the repeating variables, your density, velocity, length, and theta. Please, जिसका mic on है, please turn it off. The some noise is coming from kids. And now you are taking your next variable, which are also there, your CP, because CP is not chosen as the repeating variables. Now you have put again the dimension of that. So you are getting this actually. CP dimension is this. Okay. L square t minus 2 theta minus 1. So I wrote a mistake here. यहाँ पे m भी है. Here is m is also there is mass, heat capacity. Okay. ठीक है. So I have here mass also at this particular here you got L square t minus 2 and theta minus 1 here, CP. Hello? Specific heat. Hello?
Yes, sir.
So now I will do same balance here. Now again I will calculate what would be my powers of A, B, C, D here. By balancing these powers, again I will get constant A, constant B, constant C, constant D. I got the another dimensionless group here, that pi 2 is Cp theta upon B square. That is my another dimensionless group. Now I left one more parameter there, is viscosity, correct or not? So I will put again the third pi group here is for viscosity here. So I have the my all the repeating variables. Now I am multiplying by viscosity. Viscosity is here ml minus sorry, ml minus 1 and t minus 1. So I will again calculate my dimensional, that means the analysis balance the dimension on both the sides. So I will calculate again constant A, constant B, and constant C and D. I got one more dimension here, dimensionless group here, mu rho BL. What is this one? What is this dimensionless group? Hello?
Yes, sir.
Viscosity.
What is this dimensionless group जो आपको मिला अभी just now? Mu upon rho BL.
So reciprocal of Reynolds number.
Correct. So you got आपके तीनों आपके dimensionless group आपको मिल गया. So now you can put your function because your Q was your dependent variable, rest of are independent variables. So you got there a pi group 1, this was your pi group 1. Now you got three pi groups only, three dimensionless groups. So that was here, your group 2, the group 3. So your Q by this is function of that. So based on that, you are developing your correlations, that your Q in this case would be your function of these way. And how those would be correlated, that will come from by performing practical further. You will have some functions, some correlations of that. So this is how for each problem you will calculate now number of pi groups. Now for that, now this is what for that my fan assisted microwave. So for that you came to know these are the pi groups. Now if I converted that microwave from model to prototype, I will only consider these dimensional group. I will not consider anything read from books and everything. No. Based on my problem, these are the dimensionless group. These should be equated from model to prototype. The numbers of these should not change. Only thing the dimension can change. So if I want to make from model to prototype of this microwave, I will consider pi group 1, pi group 2, pi group 3, and these values should not change. Only thing their denominator, numerator can change. Getting the point? So let's see quickly one more problem here, because previously the explain you with how to calculate. Now this is one more problem here. You perform the experiment of the orifice plate. Orifice meter आपने किया है, और I have taught also the orifice the meter to you. It is being used to measure the flow, right? Correct? अरे any answer, just the आपका mean the response इतना slow है कि कुछ समझ में नहीं आता हो
Yes,
क्या
sir.
रहा. Now this is being used to measure the pressure for a flow of the orifice plate of diameter D, mounted of the length of pipe diameter of D, because the orifice you are putting in a pipe, it has some diameter. Now you say the pressure drop across the orifice could be a function of these many variables. If नहीं है तो आपको ये सोचना पड़ता है. You have to think about it, because you are putting in a pipe. So what could have the pipe? Pipe could have a flow of the fluid. It would have some density. It would have some viscosity. It would have some velocity. Now you have two more things, the diameter of the throat of the orifice and diameter of the pipe. Correct or not? Right?
Yes, sir.
तो यदि आपके केस में orifice है some problem नहीं है तो you think if you are thinking more number of parameters there would be no harm, but if you are thinking less number of parameters then you are in a trouble. So always whenever you have the open-ended problems are there, you think as many variables, nothing would go wrong in that way. But if you are thinking less, okay, I am taking only two parameters, then you are making a mistake. So in that case, you think as much, what maximum parameters are there, involve all of them. Now for this, they said the delta P. So you wrote all parameters first, your delta P, your density, your viscosity, your velocity, your diameter of the orifice, your diameter of the pipe. Count them. How many are these? 6. Now you write primary dimension, all of them. Here, this is the pressure, ml, this is, but here the ml minus 1, T minus 2, density kg per meter cube, viscosity ml minus 1, T minus 1, velocity L, T minus 1, diameter again L, diameter again L. So how many primaries I mean the dimensions here are there? MLT only 3. So that's what M is 3. Repeating parameters you choose in that way that all primary dimensions should come at least once in least power. Take care of that. What guidelines we gave that if you have density, choose that. If you have velocity, choose that. If you have length or D, choose that. So you have here. So these are your repeating variables M. Now also check all your primary dimension has been involved in this or not. Yes, all of them has come here. Density में mass आ गया, velocity में time आ गया, and diameter में L आ गया, right? Correct or not? So everything came here. So your M is equal to 3 here. Repeating variables are also 3. You can calculate now pi groups are here. Pi group is now n minus m. So n is total number of the parameter m 6. The repeating variables r was 3. So you got here 3 here. So you got finally 3 are now your dimensionless parameters. We do the same way calculation. Here first we want to calculate pi group. So first we calculate a involve them with first be your delta p. So delta p is this. Calculate same way dimensional balance, calculate coefficient a and b. So you got your ABC here. For that also you got constant and you finally you got here a number here delta p by rho v square. What did the number is called? I taught you here. This is nothing but if you will put a coefficient here half, it's called your pressure coefficient. Correct or not? If I'll put a half here, this is called a pressure coefficient only. So this is first a dimensionless group. Same way you now you have the one more parameter viscosity. Add with the viscosity. Again you calculate your parameter ABC. You got your constant ABC here by doing the dimension analysis balances of the dimension of both the sides. For that you got a one number again here, this mu rho BD, which is your 1 upon of Reynolds number. Now you have third group here, the diameter of the throat of the orifice. So you have just multiply by here D here. Again you calculate your constant ABC, you got a one parameter D upon D. So finally you club all the time. This is the dependent parameter. This was your delta P. So delta P, so you got this number delta Pi upon rho B square. This side you club all of them. That would be function of that. So that is RE upon T. So you got all 3 pi groups. Now if you want to scale up this or this the orifice, so you have to consider these 3 dimensionless numbers only. These should remain same from model to prototype. Is this fine till here? So this way you are getting what dimensionless numbers are involved in my project or in my question. Hello?
Yes, sir.
Just
Yes,
give
sir.
me, are you free? If you can give me 10 minutes so I can tell what you have to do from the model to prototype.
Sir, we have MSc lecture from 11:30.
11:30 ना, so 11:30 तो होने वाला कि हो गया, हो ही गया.
Yes, sir.
So this model to prototype problems is left only to explain. So you do that lecture, then we will meet again if you want to finish it today. I have only this particular component to be taught only.
Sir, वो lecture 2:30 तक है.
Okay, I am free whole day.
Okay.
Or we will meet tomorrow then. Choice is the yours.
सर आज ही कर दो सिलेबस.
तो एक ही क्वेश्चन बचा है. क्वेश्चन आप कर भी सकते हैं पुराने, बट आपको अब मतलब इज गुड all the time to explain actually, because just saying it will not help actually.